All right, welcome everyone. My name is Raf, and I am a solution architect at AWS. In AWS, I work more on cloud architecture, but front-end is my hobby passion. And today, I want to try to blend the two things together. So my first question is, how many of you have or work with front-end technology? Cool. I was expecting less. Very good. So today we talk about micro front-end. And I will give you an intro. So for some of you that work with front-end technology, may be a bit, not boring, but like you know already this, but it's just to set the ground for the conversation. So micro front-end is actually an architectural pattern, and it comes from the concept of a microservice. So microservice was an architectural pattern to segregate backend bounded context in order to allow multiple teams to work in parallel and develop multiple functionalities without being tightly bound together. And the concept now is similar, but for front-end. So micro front-ends is a technical representation of a business subdomain, also known as bounded context. And the idea here is, what problem do I want to solve with micro front-end? So the main idea is you want to have loosely coupled UI modules so that you can carry over development of products, specifically front-end products, by multiple teams without being tightly bound together. So that's when you want to use micro front-ends. So as Amazonian, my approach is always, what problem do I try to solve? And if you don't have this problem, my first sentence would be, you don't need micro front-end. Now, let's deep dive a bit more on this, do I need micro front-end? And also, what are the decisions that you're going to make to implement micro front-end? And I have divided this first part in 4 different areas. So the first one is definition. So let's define what is micro front-end. Then how you compose a micro front-end application, and how you can deal with common problems like routing, communication, and state management. After that part, I will move into a different section of lesson learned of what not to do when you use micro front-end. So first of all, Webpack. How many of you knows what is Webpack? Okay, so Webpack is an open source JavaScript module bundler. What it does, it takes one or more JavaScript files. If you look at Vue.js, React, or Angular, it also includes additional files like stylesheet, HTML, and it bundled together into a JavaScript module. That module, you can host it on NPM, on Yarn, so in a remote repository, or you can link it in other JavaScript projects. So that's the tool that we're going to talk about today. Some of you may be aware that Webpack offers module federation. So in reality, already today, in any Node.js platform, so React, Angular, Vue.js, even vanilla JavaScript, you can leverage module federation to dynamically load modules that are built in JavaScript. And the way it works is very simple. So we have, on the left side, multiple micro front-end, so MFE stands for micro front-end modules. It's built by one or multiple teams. Then through Webpack, we are going to do module federation, and these are the result, the chunks.javascript. Those chunks can be deployed in a cloud bucket, can be deployed in a shared drive. It's not really important, but what you can do with module federation, you can dynamically load your UI component by using Webpack module federation and dynamically loading your JavaScript file. And the way it works, it's quite simple. We have 2 different areas to look at. The first one is the remote. So here I have a module that is called sign-in. Inside this module, I can have multiple UI components. So I will say to Webpack, what is going to be my chunk.js? In this case is remote entry.js. So this is what Webpack is going to produce and host it outside. Then I have an alias, so the name of the host. So if I want to use this module, I will have to do an import with the name signin. Additionally, I can say this module has dependency, because maybe the signin module is using, in this case, React, and I can also say that this specific dependency, it's static. So by doing that, by using singleton, I inform Webpack that if there are other modules that need to use this specific dependency, they don't have to reload it every time. And this is how I declare a module. Now, how can I consume this module? I can consume it from an application shell. So application shell could be, for example, the skeleton that you have in your user interface. And in there, you want to log in, so you want to load the sign-in. And in here, we have two different aspects. First of all, we need to tell the application shell where is the module that you want to dynamically load. So in this case, it's inside the remote. And I'm saying that I want to load a module named sign-in, and this is my location. And the second part, again, I can still specify if I have shared dependency. So in this case, because it's a React application, it's always React and React DOM. And this is the final result. So of our step, we define what is micro frontend, and now here we are looking at the composition. So around here, I have my application shell, which is always the same, and is aware of the module. And then what I see often is that inside the application shell, navigation is embedded because it's aware of module location. And then by navigating through my navigation menu, I can dynamically load different modules. So going back to the problem that we are trying to solve, by using this approach, I can delegate to 3 different teams, different area of application development. In Amazon, we have a concept called two-pizza team. So the idea behind that is that we believe that a team shouldn't be bigger than the amount of people required to eat 2 pizzas. So usually it's 3, 4 people. The reason for that is because you want to reduce to the minimum the management effort to keep the team independent. So in this case, I can have 3 different teams, so 3 different two-pizza teams that can work on different functionality of my product, and they're fully independent, but not entirely. So in here, I have a monorepo. In this specific case, the example that I show you is a single repository on Git with different modules. So I have my application shell, I have account details, catalog, sign-in, which is the one that we saw. Then in sign-in, it's actually inside the folder sign-in, what I have a sort of mini Webpack application. So in there, I have all the JavaScript, CSS, HTML files that I need to build and keep this module independent. Then inside Webpack config, I can instruct Webpack of what to do when I want to bundle this module. Now, I will deep dive a bit on different aspects of those specific modules here to discuss a bit how can we address problems like routing, how can we address problems like sharing information when the modules are not aware of each other. So the first one is the shell configuration. So in this shell configuration, I am declaring a module plugin, and I'm informing the shell that has the capability to consume 3 different modules: my account, catalog, and sign-in. And then you can see that I'm using localhost in this example, which imply that those 3 different JS bundles, they are public hosted somewhere so that the shell can consume it. And then I have my shared dependency, which I discussed before. Second part, routing. So let's say that I click on the navigation menu that we saw before in our mock, and I want to go into different routes of the browser so that I can consume different UI within the module. How can we do that? In the previous screen, we declared the module. In this screen, we import. So I have catalog, sign-in, and my account. If you are not familiar with React, React Lazy is a function that what it does is only when the DOM render the content, it's physically calling that JavaScript chunk. And then in here, I created 3 different routes. So I have the root, which is going to load the sign-in page. And then I have my shop and my account. And this one, it's configured inside Webpack in the following way. So what I have here, I have my declaration of the module and the sign-in. And then I'm telling to the sign-in module, you need to be exposed as sign-in. And here I have a bit more dependency than the previous example. So this is like a real application. I'm using Material Design UI, which is the one provided by Google. And then I'm using React and React Router DOM. Then we have established this concept. So now we have our shell. We have the sign-in area. But inside the sign-in area, we need to start to put some logic of when the sign-in page should be displayed, because maybe the user is authenticated, so we want to store the authentication token somewhere, and we want to ensure that in that case, it's redirect the user to a specific page. So how do we share token in a micro front-end application? First of all, we need to get rid of the concept that modules are aware of each other, and we are inside the browser. So the browser, if we look about Chrome, give us 2 different storage. One of them is called session storage, and one is called local storage. What you can do is you can start to structure your module to be aware of having an external unstructured database, which is a session storage. Now, the evil here, it's in the details. How the other modules are aware that I'm storing a field called token, which inside contains the JWT token. So when you build a module and you start to share information and you decide to store the information in session storage, for example, or inside a cookie, it's fundamental what is called documentation. I know that most of you hate it and hated more to read it than write it, but in this specific architectural framework, it's really important to explain to the consumer of your module what they have. So what kind of information they can store, what information they can retrieve, and what events the module is sharing with the audience so that you know how to interact with the module. Now, in this case here, just to very briefly, you sign in, the JWT token is provided, is stored into the session, and then there is a history push, which is redirecting the user interface into the service in the product catalog. Now, product catalog, then we have to deal with internal routing. So now we told the shell that if we go to different paths in the browser, we can load different modules. But what if I want to go into a nested view of a specific module? So in this case, I am in the browser inside /catalog, and now I display a list of products. And I want to click one product, and I want to stay in that module, but I want to dynamically load the HTML code that display me the product details. So here we have to now think about what is called local routing in React. But you can achieve this also in other UI frameworks. So in this case here, we need to start to think about how we can leverage query string parameter in the browser so that we make the view internal to the module aware that we want to stay in our path, so in our /catalog, but we want to look at a specific product ID. What is important here is not this very simple code that I wrote to show you the logic behind. What I'm trying to display in those slides is now I'm coming up with a bunch of rules, a bunch of guidelines that should be followed across all the modules. So now we establish 2 main rules. The first one is /name will represent one of the micro front-end module that my company is building. And then nested navigation inside the module will be represented by the name of the entity that I want to represent and the unique ID. So now this is the rule that I'm expecting in every single module that I'm going to work with in this project. That was for the sign-in. Then how can I actually compose the logic? So in this case here, we have an additional module, which is the My Account. So if I look at this declaration, I think that the My Account module, it's a module that is loaded after I'm authenticated. And then in there, I can see information about my account, like account details module and payment details. So now we are having nested dependency. I have the shell that is aware of sign-in. Sign-in is aware of my account, and my account is aware of two additional modules, account details and payment details. And later, I will show you like why here something is wrong. But you see, now I'm building all this dependency, and going back to my previous statement, we need to remember to document all of this dependency. Otherwise, someone in payment details may start to play around and may affect our module. In the final composition here, this is a standard React if. So what happened here? When the My Account view loads up, you verify if there is a token. The token is taken from the session storage. So you see here, the My Account module is now aware that there is a session storage field, which is where the module communication needs to happen between teams. And then it's simply deciding to display information about the account or to display different information if the user is not authenticated. And then we have two more steps. So here is the final composition of the My Account. So the My Account is using a specific functionality of React to display two different details. So here I may have a table with all the details of the account, and then an empty line and an additional table with the payment details. So you see, it's all dynamic. So the person working in this specific area here doesn't need to be aware of what's inside account details and payment details. Last part is the communication. So now we have all this abstract composition, but how can I communicate? For example, I am into my product detail view, and I say add to cart, but I'm adding this item to a shopping cart module, which I'm not aware of. I don't know how it works. I don't know even if it exists. So how can you completely loosely couple this? You need to go into what is called event-driven. So you need to emit and consume event. And again, also here, when you go into the concept of emit and consuming, you need to be aware of what you are emitting and documented and what can be consumed from a specific module that you are dynamically loading into your UI. So in this case here, this module specifically is emitting an event. The event is called payment change. So if you're familiar with how Google Chrome store information, you will have a key value pair. The key is payment change, and then I have May 2021 as a text. And then somewhere else, we have somebody that is subscribed to the event. So in this case, I'm telling the browser every time an event of type payment change happen, do something. So in this case, the UI, if it's loaded in the browser, will refresh automatically. And this is the first part of micro frontend. So what it is, how you can compose different modules, and what are the aspects that you need to be aware of. So routing, nested routing, storing information in the browser, and emitting and consuming events. Now, all of this, it's super beautiful, but it's also really static. So there is nothing loosely coupled here. Because in reality now, we are saying to the team that is building the application shell, hey, you need to be aware that you need 4 menu items because we are going to give you 4 different modules. So we didn't loosely couple anything. We hard-coded all of it inside the shell. So originally we had those, they were called SPA, single page application, where jQuery came out, and it was beautiful because it was a single page, which was dynamically refreshing, doing Ajax call. But now we are moving into a different concept. We are going into micro front-end deployment. So in reality, our application, it's unaware. And then we have modules that theoretically can be loaded into the UI. But what is the problem that we are facing with this approach is that today I mean, there are some, but today there is not an opinionated discovery and delivery. So if you're familiar with microservice has some mandatory requirement in the architecture. There is an API gateway, and there is API discovery. So service that allow the consumer to be aware of what APIs are available, what version is available, and how it is documented the payload. We have to use the same approach now if we want to go into micro front-end. So we need to move from static into dynamic. This is a static import. So in here, I have a JavaScript block where I'm informing this specific web page of some import. And this is for a standard SPA, so single page application. Then if I go into what we have seen so far, I'm doing the same. So here I have my plugin declaration. So this is my React application. And in here, I'm informing where the modules are located. So the main problem that we have here is that this consumer is really bound to the availability of the modules. Let's think for a moment that we want to have multiple versions of the modules. Now, in here, I will have to create files like remote entry _1 _2, and every time something changes, I need to go back to this consumer and update all those entries if there is a new module, if a module becomes end of life, because it's hard-coded. So what about having this dynamic? How can we make a JavaScript user interface dynamic so that it's not aware anymore of what to consume, but it's capable to consume? So we can think about this. We have an agnostic application shell that is not aware of anything except how to call a remote repository that will tell what modules are available. And this is the idea overall, is to have the same identical architecture pattern that we have for microservice. So in microservice, what we have a gateway, and the gateway is your abstraction from everything else. So you, application cell, are only aware of the gateway. And what is doing the gateway is actually calling an internal repository that will give you the list of available modules. So every time a team works in a specific module, in their CI/CD build, what they will do, they will simply push information into the service registry, saying, hey, I am product version 2 now, or I am a new module and I'm available at this URL. And then the shell will interact through the gateway, so it will face a full abstraction layer that is not aware of the internal implementation. Then we are making now independent not only the teams that build the modules, but also the team that build the application shell. But it sounds beautiful, but there are challenges. So what are the 3 main challenges that you can actually address if you implement dynamic loading correctly? So first of all, versioning. We're not anymore in a situation where, think about the big CRM application. I will not mention any commercial name, but think about CRM that have SaaS impact, so they are available online, and every time they do a release, is affecting all the users. So first of all is how you're going to manage versioning, because maybe you want to have a canary deployment where just few users can test the new functionality. You want to de-risk the deployment, so you now with everything loosely coupled, you don't want that a single team can push a module and break anything that is out in production. And then at the third most important is fallback alternative. Because you're using remote loading, that doesn't imply that it's always there. We have seen that even cloud provider can go offline for certain moments. So you want to implement a strategy where your application is capable to keep running, even if it's not capable to load the functionality that allow the application to run. I talk about the deployment strategy. So here is 2 of the many available deployment strategy. The first one is called blue-green. So in blue-green, you have 2 instances of the same application. At the moment, you have all the users inside your catalog version 1 to 1, and then you switch, and everyone starts to use the new version. It has certain implication, this approach. You have to be sure that the version 1.4.0, for example, it's working and it's working for everybody. But when you do web development, you're dealing with a lot of browser version and other aspect that maybe they're not really the best fit for blue-green. So we can think about canary release. And canary release is a way to offload certain user to a specific version, use them as tester for your new version, and when you're comfortable, when you collect all the information that you need to verify the new version is working, then you switch them. Now, beautiful, but we were talking about micro front-end, and we were talking about how to decouple modules. So how can we now inform our teams that we are going to deal with Canary Islands? So we're talking about deployment now. It's a bit different topic. So the idea behind that we have in AWS is to actually structure a naming convention. So the idea is to have a mechanism to build multiple modules of user interface framework and to specify all this information. So in this specific definition here, I'm saying that here is my micro frontend URL. So this is the URL somewhere that I can call to understand what are the modules available for me. Here is a fallback for whatever reason. No connection to the repository, browser goes offline, you name it. And here is some metadata that I can use to enhance further my application. So in this case, for example, I want to use versioning, and I want to use some extra functionality. But now, how this goes into blue-green and canary release? So we can enhance it further. We can now start to inform our UI about not only the versioning, but for example, I want to do a canary deployment. So here I want to redirect 30% of the traffic into this specific version of the module. I want to, I want to also provide other information for fallback and for additional modules. And all of this is actually now a project. So this project is available on this URL. You can go there, and you can try yourself. So the project implies that you can build the infrastructure on AWS. And now I will very briefly show you what it is, this infrastructure. Can I ask how many of you are a little bit familiar with this service on AWS? All right. So I will try to make it super simple. This is an infrastructure. So it's a set of services that you can build on AWS. And it has two entry points. The first one is the admin user. So the admin user is nothing else than your CI/CD pipeline. So every time your CI/CD pipeline builds your UI module, it will call this infrastructure and push a new version of the JavaScript chunk, which is stored inside a NoSQL database. The blue icon is a NoSQL database. It's called DynamoDB. So what happened here, the admin user can be a physical developer or can be a CI/CD build. You build your new version of the module, and you store it online. Then on the other side, we have the consume user, which is nothing else than the application shell. And now the application shell will go into a different, the red one is an API gateway. We go into a different API gateway, and this API gateway is actually capable to query and verify what modules are available and how they can be dynamically loaded. I know it's a lot, but I will try now to give you a recap of what we discussed. So first of all, if you want to go into micro front-end, but this applies also for microservice, the discoverability, so the capacity of your product to be discoverable from outside, open a lot of new opportunity. And Additionally, improving the discoverability and deployment strategy of your product make it less risky. So now you have this capacity to deploy a new version, test it out without breaking the main product. And again, this is the URL to try it out, and then it's a GitHub project that you can follow. Now, this is my first part of the talk, and I can see that I was quite good on timing. Now I will go on something that can be a bit more interesting. So here is 6-7 lessons learned of what you should not do if you want to work with micro frontend. So the first one is the yin and yang, which is a mistake that I see often not only for micro frontend, but in general with teams that work with UI framework. So this can be Vue.js, can be React, can be Angular, you name it. Which is, what are you building today? Are you building a micro frontend module, or are you building a component? And what's the difference? So now I have an orange square. And the orange square has a label. And then I define that the label has to be orange. And then I want to be able to change the border color. And I want to be able to have different rollover animation. I want to be able to auto-size this square, this rectangle, and I want to make it disabled by default. So what is this? Is it a component? Now, same square, so visually look the same, but I want that it is independent. So it's not aware of style sheet, it's not aware of positioning, it's an independent thing. Is domain aware, so it's aware that there are events emitted around the browser and there are information stored in the session storage. E may have input and output, but is not extensible, so I cannot enhance it further for my project. So this now, it's a sort of decision framework, and should help you to understand if you're now in the need of building a component or an independent module. For example, this UI, they are all component, so are they really component? So the point for this first lesson learned of it's a component or it's a module, it is really like to make decisions that will affect you on the long term. So it's not really super agile dynamic decision. It's very important to understand what we're building here. Is it a full module that I will reuse somewhere else, or maybe it is bound to a specific module, so then it's a component within the module. The second one is multi-framework approach. And this is actually what happened in the past also with microservice. Microservice was born, was created at the beginning because we had big financial company, big enterprise company with multiple systems. So what they had mainframe, they had Java, they had .NET, they had Python. And they want to be able to consolidate all this API, but it was too expensive to rewrite all of them into one technology. So what we do, we build an abstraction layer on top so that everyone can consume in the same way different technology API. And it's the same for micro frontend. You will not go back to the office today and say, hey, you know what, we have everything in Vue.js, we need to rewrite it because it's micro frontend, we want to use React. No, you can have multiple teams, and you can have today remote working. So multiple teams in different countries may use different framework. And that's totally fine. But it's important to establish boundary. So the question that you should ask yourself is, if you are building a single page application instead of building a micro front-end architecture, how many UI library or framework would you use? If you start today to build a project, would you pick up Angular and React? Probably not. Probably you would choose just one of them. So here is the same concept. First of all, you will say, I want to use different UI framework or libraries, because I'm dealing with legacy system. So I need to now harmonize a system that has been built in the past and is a mix of different UI framework. Or I want to migrate to a new UI framework library, and you know that migration of technology takes years. Or you are acquiring a new company, or you are the company acquired by a new one, and then in this case, you have the necessity to change technology. So those should be the three main reasons. So the point is, it's like before, use it if you feel the need to do it. So if you see that you are in a situation where you're dealing with different UI technology, then you can go ahead with it. But don't build your architecture because you say, you know what, we want to be ready for the future, so let's build our micro front-end architecture to be capable to use different UI framework. That would be the wrong approach. Now, third one, Swiss Army knife. So I'm Italian, but I live many years in Switzerland. And the first things that they do in Switzerland when you have a boy is when he's reaching the age of 18, every year he will go to military service. It's a bunch of weeks every year until the age of 34, something like that. What they give you the Swiss Army knife. So the Swiss Army knife, I think most of you know it. It's a little knife, red, on both sides, and inside there he has everything. So you have a blade to cut wood, you have a blade to cut paper, you have a small knee to seal clothes. So it's one single thing that does too many, it's capable to do too many things, right? And here is a bit of the paradigm the other way around. So you need to write programs that do one thing and do it well, which is also the single responsibility principle pattern. So let's look at the Greenfield project. I have a Greenfield project and I have one module, module A. And this is like a list of customers. So inside here, I have a view with a list of customers, then I click one, and I can go into the customer detail. Then we come up with another component, so another bunch of UI view components, and they are segregated into two different modules. But they are tightly bound together. You see the dashes around because they speak to each other. Now, I want to let them all communicate. So probably I put a storage in between, which is the example that we saw before with the session storage. So now I have a third component that allows them to share and store information. But this is for a Greenfield project. But what about a legacy editor? So if you have worked with web application, there is one component called TextEdit. So TextEdit was built years ago. It's vanilla JavaScript. And it's an editor that probably most of you have used at the beginning when you interact with products like Facebook or Twitter. They have their own editor, but it's the same concept. It's this web editor with tons of buttons where you can make bold, italic, underline text. And behind TextEdit, it's capable to do things like export to Markdown, export to plain HTML, but it's legacy. You have to import a JavaScript file, and you need to interact with the core API exposed. So if you have the same problem, one good practice is to have an anti-corruption layer. So the anti-corruption layer is nothing else than an abstraction that you want to put outside your legacy UI code to make it kind of invisible, so that you make it more ready for modern JavaScript. And then the other 2 points is that now your legacy component is ready to be consumed by more modern JavaScript framework or libraries. So the lesson of this specific example to be learned is you want to spare the application shell code base. So don't pollute the shell code base because you have the necessity to deal with legacy code inside your company. But try to build anti-corruption, so abstraction layers around the legacy part, so that your new code, so your shell code base, stay clean. Then one that it's very difficult to understand when you start to work with React. So retro ticket, please. And this is like a concept that I also struggled 10 years ago when I started to work with React, and I was not understanding why the information in React, they cross the DOM in one way only. So they go top down, but you cannot go back. To make it simple, if you try to update information inside child element in the DOM, you can do it in React, but you cannot traverse the DOM back and refresh the parent container. But there is a specific reason for that. So here I have a host and a remote, and let's say that host is the shell, and remote is a component within the shell. And in this case, they speak to each other. What is the problem with that? The problem with that is that we have Flux, which is a well-known pattern also used by library like Redux, where they explain you why you should not have bidirectional conversation when we talk about user interface. The reason for that is you want to have only one way to update the information. So if that information now is capable to update itself, you can create damages in your architecture. So the idea behind this is that there is only one way to update the information. Then if the child component needs itself to update again the information, there should be a notifier, an action, that go back to the information storage and refresh it. So the UI should be subscribed to this information storage. Every time the information change, the UI refresh, and every time you want to change the information, you go through an action, which is like emitting an event. And this is really important because it has one single flow for the information. So it's easy to debug because you know who is in charge of modifying the information, which is only the action, and it's less prone to errors because you know that there is only one flow, which is left to right. So information storage to user interface. Here is a very polite sentence, which is avoid bidirectional sharing unless strictly needed. I would get rid of the second sentence, but I cannot do it for this deck. Avoid it, don't do it. Build an architectural pattern so the user interface data binding is always refreshed one way. This one, pretty easy. So you are building code, don't get bound to your organizational structure. So global state, let's say that we are using Redux and we store all the information. For example, you go to Amazon.com, you click a product, that product update the number of items in the shopping cart in the top one. That information is stored somewhere in the browser. But now, with a global state, all these modules are aware that there is a field, number of products in the shopping cart, which probably they are not interested. So why not going into emitting event? Module A, buy a product, emit an event, and another module, which is the one in charge of displaying the shopping cart, will simply subscribe and update the amount of item bought by the other module. So loosely coupled, it's fundamental because allow you to keep your module independent. Then I have two more. Here is on the API. So this is another big problem that I saw, not just with micro frontend, but in general. We have an application with 4 modules. And what happened is 2 teams decided to consume the same API. And then you deploy this on AWS. You use some technology like Kubernetes or serverless to have the API hosted. And then you call us, say, hey, you know what? It's overloading, and I get throttled. When you get throttled, it means that you call the API, and the API doesn't work. Why is that? Because now you have 2 separate modules, in this case, that they're calling the same API. So let's rethink about it. What about we have 2 modules, but now they speak with an abstraction layer. So we go into the microservice concept. We are not aware of which API we are calling. I want get product item or get product list. This is the API that I'm calling. And then the gateway provides service for authentication, provides service to interact with the API number 1, But the API number 1 now, it's connected to some other different API. So we are not aware anymore. We just go through the API gateway abstraction concept. And this is how we can solve it. I say we have 4 modules, but 2 of them, are they really modules? Because they're speaking with the same information. So they are aware of the bounded context. And in the first slide that I show you today, I actually mentioned, right, we want to use a bounded context. So what about we now make 1 module and 2 components, because they consume the same API. So here is lesson, try to understand the impact of segregating modules and components, because you will pay the trade later. And the last one is bye-bye Big Bang. So we look at how to do iterative deployment. And what happened here is you want to build a migration strategy. We have a monolith, single-page application. We start to build modules. From the module, we start to develop a single one. So I have everything in the white and my new micro frontend module / catalog. Then I start to break it further, so I have additional module, and I can continue if I need to. So the lesson here, trade-off. You need to find your own way in your own project and decide if you want to micro frontend everything or just a portion of it. And I think I see here that I'm kind of in time, so there is a bit of time for questions. And I hope after lunch I didn't annoy you too much with this.
Thank you very much. Big round of applause, please. Thank you. Thank you very much. Okay, we're going to take a few questions. So are there any questions in the room? Please raise your hand. Right here in the front.
So I wanted to ask a bit about the domains of micro frontends, because you mentioned them. So I understand there's the business domain, but there's also the business concerns, so to say. So for example, a user of the same application can be of various roles, right, that have different impacts, but realistically are still speaking with the same data of the same concern. So be it a user list, you can have the user looking at its friends list, or you can have an administrator, and let's say the view is the same, right, or at least similar. How do you decide when it's time to separate those into modules, although they are of the same business domain, but they're separating concerns versus keeping everything and controlling via state?
All right, so I give you an Amazonian answer. It's always about what problem do you want to solve. So microservice, and some of you may disagree, huh? Microservice and micro frontend, they solve one single problem, which is making development faster, keeping teams independent. So to answer your question is, who is going to work now if you have one set of functionality and you split into 2 modules? Is it the same team working on it? Because it's not improving performance. The purpose of a micro frontend is to segregate functionality so that you can develop them in parallel. But if the same team is working on 2 modules, you don't have any benefit. So you may not need to.
Then follow-up question would be, looking at long-term perspectives, especially with growing businesses, there's always the potential for teams to grow, right? And if you apply the 2 pizza rule, that means my single team right now might split into 2 teams or 3 teams later on. Do you think it's valuable to try to mitigate the future risks, or rather take it one step at a time? Since it's components, maybe trying to separate something?
I have my own view based on, I see a lot of customers, and what I see is the biggest mistake they do is overthinking, over-engineering. So it's very responsible the way you think about it, but you don't know. So I would understand a CTO having this concern, like, hey, I see my company in 5 years from 30 to 300 developers, so I want that everything gets abstract. I want that everything gets CI/CD, because I know that I'm going there. But as a developer, so as a software engineer, I wouldn't look that far. I wouldn't have that concern if it's not concrete. I fully understand you, but if you use that approach, everything for you would be something that need to be taught very deeply, because it will grow. It may grow, right? And I am more pragmatic on this. So I tend to say, well, if I hear the bus coming, I start to move because I hear it. But I will not constantly walk and be afraid that I hear a bus coming. If I don't hear it, I don't react. So to answer you would be the same. It's like, if you don't have that need, don't have the concern. Have the concern when you start to see that it's good. Of course, clean code, of course, clean architecture always. Doesn't mean you write crap because you're not going to segregate it later. But don't be, because otherwise you over-engineer everything.
Thank you.
Thank you. As a reminder, anybody who asks a question gets a little gift, and at the end you get to choose the best question and give the big gift.
All right.
So, next question right here in the front.
So first, thank you very much for the presentation. My question is about the performance. Is that if we will use a lot of, let's say, bundles in one website, for example, will it load, for example, React twice, and will it affect the performance of the website if you will use micro frontends a lot in one website?
It does. So in my slide, I know I show you a lot of slides, and if you're not a React developer, maybe a bit overwhelming. But I was always using a component called React Lazy. What it does, React Lazy, it's dynamically loading JavaScript. You pay the price for that. Now, here in Lithuania, you may all have fiber connection at home, so you don't care. For 300 KB of JavaScript file, for you it's nothing. But think about someone that is developing a remote JavaScript application for mobile. And that person, mobile, is maybe somewhere remotely in Asia where they don't even have 3G. You will see the performance. And you need to design everything taking into account that data is loading and may not load. So it's the fallback concept. So the performance is affected, yes, because the browser at the beginning is like this, loads super fast. But then every time you do something, it starts to pull JavaScript from the internet. So you need to design everything in a way that take that into account.
Thank you.
Thank you. We had another question in the back.
Thank you for the presentation. I have a question about the learner. You mentioned that we need to split the components and micro frontend. And my question is, any additional concerns about the learner? Because I guess that we can use the learner to split not only the components, but the micro frontend too. And I got that we have only one problem with the different frameworks or any else concerns about the learner. Thank you.
Well, I think one aspect that I didn't want to touch in this presentation because it was really specific to front-end is we didn't talk about the most difficult part of front-end, style sheet. Now, we say that we have independent modules, but we should have a design guideline that span across all the teams. Otherwise, you create a button red, I create a button green, and then when we put it together, kaboom. So you want to have a naming convention also, because you blend all these style sheet rules into the same DOM element. So what you call .btn, it's your gray button, and what I call .btn is my red button. And CSS, the way it works, the last rule that is loaded is the one that overrides everything else. So one other aspect between module and component is design library. You need to choose one. You need to choose a day one. You need to choose design convention, and everyone has to stick to it, especially layout, like liquid layout. If you build a component that say I'm 300 pixels wide, and then my shell is designed to be liquid, so adjustable by the resolution, When I adjust my whole application, your component will pop outside of the boundary. So design is one aspect that I think is really important. I just didn't include it here because I think it's more for a different audience. But yeah.
Thank you.
This is a good question. How many web developers here? Raise your hand. Okay, cool. Thank you. Next question. We had another question there. There's one right here. Mahmoud.
Thank you for talk. I had experience working with micro front-end using Lerna, module federations, and we moved on. It was way too complex to handle it and get it right. So it was following up to the first question that you had. So we had one monolith, and it was different domains, but we had 30 developers had to handle the same code. So from the business point of view, we had to decide we need to split these domains. So we went from monolith to fall into micro front end. And unfortunately, from my own experience, that I see micro front end for every single organization, they understand it on their own term. But from me, it is domain separation or decoupling the domain. I have two questions regarding to the micro front end. One of them, how would you handle if you depend on other front end? I do know that it should be handled by the business, that we all need to be aligning to roll out whatever that needs to be rolling. But if you are relying on something like technical dependency, say for React, and you're using Vue, but you're using, I don't know, Lodash, and the Lodash has some broken changes, and you're sharing these data between them, how would you handle this dependency? And the second question is more related to the service discovery. Is it only AWS? If it's yes, could it be applied to any other things, or where would it start to apply to other provider or in other stacks? Thank you.
All right, so the second one, no, is abstract. So service discovery in micro front end and microservice for the backend is applied to anything. You can have service discovery hosted in your PC. You don't need cloud, you don't need AWS, you don't need, I can tell you for other CSPs what service you need. It's called API management in Azure. It's called API gateway in AWS. So you can apply the concept anywhere. The discovery is you have a service that is like a database. You query and it tells you what's available for you. The first one, again, it depends. So if you end up in a situation where you have big teams working like in a big CRM and you use different UI framework, I still believe that the old school communication is the key. I would say communication, many of you may disagree, but I truly believe in well-done documentation. I think it's needed. If I go to GitHub and I see a project with 10 files, but the person didn't even tell me in the README what is it, I need to waste my own time now to deep dive in it and try to understand, is it what I need? So I'm a kind of a boomer almost, I'm 46, and I truly believe that well-done minimal documentation help you on all of this.